Hi, my name is Joe Disher, and today I'm going to talk to you about the great migration to the cloud. I'll be diving deep into the world of AWS storage and giving you the lay of the land to help you better plan your move to the cloud. I'll start by covering the major challenges of on-premises storage. Then I'll shift gears to go into more details about the various AWS storage services and some of the most common use cases. I'll then talk about what the journey to the cloud can look like. And finally, I'll wrap up with a summary of how to choose the right AWS storage for your specific use cases. There are definitely some challenges when deploying and managing on-premises storage. Let's talk about that. On-premises storage solutions have a consistent set of challenges regardless of the technology being used, and it all boils down to time, cost, and complexity. First, there's a time element. It's not uncommon to see long procurement timelines, such as 3 to 6 months, and that's after a budget gets approved. Implementation also may take several weeks or a few months. This negatively impacts our customers and their customers. Either way, you can't deploy the products and applications to support the demand. They can't scale to support growth, or the process took so long that requirements changed or they found another way to launch. For example, on AWS. In extreme cases, I've seen hardware sitting in a staging area for months or over a year, waiting for infrastructure to become available: power, rack space, network cooling, etc. Agility is one of the benefits of using AWS, and our customers want to reduce their time to market, but also time to value, which allows you to provide value to the consumers of your applications quickly. Secondly, there's cost, both for procuring the gear and also the unforeseen and sometimes hidden costs. I don't know about you, but I never liked when vendors came to me with an amazing deal this quarter. Where was the deal last quarter when I was looking to purchase the storage? Anyway, you always need to consider the upfront capital expense, or CapEx, where you have high upfront capital investment. There's always some guesswork on how much storage you will need, guesswork on the type of drives, the mix of SSD versus hard drives. There's additional costs for software, backup, disaster recovery, etc. There's warranty renewals, and of course, physical considerations such as space, power, and cooling. You don't have instant as-needed scalability, and when you deploy on-premises hardware, you need to scale. What if you need to scale up? Pay more for trays, racks, rooms, data centers, so on and so forth. This isn't easy. And how about features you need, such as replication for disaster recovery or business continuity? And you find out you need to pay more just to enable the basic features you expect to be delivered as part of the product. I'm guessing that going back to management asking for more money after spending on infrastructure is something you don't want to do. At least that was the case for me. I mentioned replication. What if that's a requirement? You may need to deploy the same infrastructure in another data center and use licensed products and tools to sync data between sites. Not only does this likely double the cost for hardware, but you'll need the network, data center, rack space, and you may need more staff. Let's say your team gets funding and everything is deployed. Well, congratulations. You're not out of the woods yet. The third challenge our customers tell us about is complexity. You may need specialists to keep your environments online, and in cases where you need disaster recovery or HA, you'll need to make sure your sites are staffed with the right skills, and that your specialists are close to the data centers so they can get hands-on gear ASAP if there's an issue. Let's talk about that. What if there's a problem? What if there is any type of hardware failure? Well, guess what? That means more time, more cost, more complexity just to get things up and running. So at AWS, we have lots of storage services available to help you with all your IT solutions and applications needs in migrating your storage to the cloud. AWS has been helping enterprises on their cloud journey for almost 14 years. Moving storage workloads to the cloud has been one of the main ways CIOs have been able to address their top strategic priorities, such as increasing their organization's agility, accelerating their ability to innovate, strengthening their security, and reducing their costs. Enterprises can be more agile as they scale resources up or down at any time and add new services in an instant. Innovation is accelerated by eliminating data silos and extracting more value from data by using machine learning and performing large-scale analytics. Security is strengthened as companies gain far more telemetry on their data when silos are erased. Encryption controls are more advanced, and they inherit all the controls, tools, and certifications designed for even the most security-conscious organizations. Finally, enterprises can reduce costs with a flexible buying model and the elimination of over-provisioning, refresh cycles, and the cost of maintaining storage infrastructure. Cloud storage is far superior to the on-premises model and addresses the CIO's top priorities. As I mentioned, we have a very broad and deep storage portfolio at AWS. Our major categories of storage are broken into block, file, and object. Block storage service such as Amazon EFS is ideal for applications that have high performance, low latency requirements for dedicated application servers or compute nodes. File storage, like what you get with Amazon EFS and Amazon FSx, are great when you have applications, users, or groups that are already using a standard network file sharing protocol to share data and need the flexibility and scalability of the cloud. And object storage with Amazon S3 is perfect when you have the need to scale to tremendous capacities and you want to take advantage of all the economies of scale and cost that cloud storage has to offer. We also have hybrid solutions with AWS Storage Gateway. We have lots of data transfer options with the Snow family of hardware solutions for migrating data into the cloud, and DataSync and Transfer for SFTP for copying data to the cloud or within the cloud. And we can't forget AWS Backup, which provides a single interface, policies, and reporting for helping to manage your AWS backup tasks. I'll dive into these in more detail in just a bit. So I thought it would be good to highlight some of the significant innovations that we've had over the last year. I won't go into all the details that you see on the slide, but you will be able to download and watch this presentation later if you want to read through the details. Some of the more significant innovations for S3 and object storage have been around security and the ability to block public access quickly and easily, and around the ability to deploy mass changes with S3 batch operations. Significant innovations that no other cloud provider can offer. On the file storage side of things, we've recently reduced the cost of our infrequent access storage class for Amazon EFS. We've also introduced direct integration with your on-prem AD with Amazon FSx for Windows File Server, and we've made it easier to get started with FSx for Lustre with a lower starting capacity. We've been busy with block storage as well, adding a new data lifecycle manager for managing your EBS snapshots, doubling performance for our highest performing volume type, IO1, as well as improving performance up to 60% on our other SSD volume type, GP2. We didn't stop there. We also added 2 new data transfer services with AWS DataSync and AWS Transfer for SFTP. So let's talk about some common use cases we see frequently taking advantage of the cloud. There are multiple models for backing up data. Historically, backup has been done on premises within a corporate data center utilizing backup software from backup vendors, media servers, and dedicated backup appliances. For long-term retention, data was typically archived on tape, taken off-site via a third-party service. This model is still widely employed today. With the onset of the cloud, a new model emerged whereby the cloud could be utilized as a backup target with data access to the cloud enabled by the use of a gateway device or by native cloud connectors offered in the software packages of most backup vendors. This allows customers the opportunity to eliminate backup storage appliances in favor of a remote, more scalable alternative. We are also seeing a third model, a cloud-native model, whereby customers running workloads in the cloud have a need to back up those resources, manage the backup operations, and ensure adherence with compliance requirements. Cloud-native data protection has been in place for many years, offered as a feature in many cloud-native services. This service centricity has resulted in some new customer challenges, which is why we created and launched AWS Backup in the beginning of 2019. AWS Backup can assist in addressing the challenges of protecting cloud-native applications and can be used to support some hybrid cloud backup use cases as well. Bottom line is that AWS offers many scalable solutions to augment or replace on-prem backup, archive, or DR solutions. Let's talk about business-critical applications. Companies often focus on lifting and shifting enterprise applications like large ERP systems such as SAP, media management, and high-performance computing to the cloud, along with their storage. The vast majority of these applications don't need to be redesigned to run on AWS. AWS has solutions that let you lift and shift those workloads as is, and then evolve at your own pace. Amazon EBS provides high-performance block storage for SAN or other block storage workflows, such as relational or non-relational database applications. Amazon EFS provides Linux file storage, and for Windows applications, customers can use Amazon FSx for Windows File Server. For high-performance computing workloads, or high-performance file needs, Amazon FSx for Lustre can provide an easy on-ramp to the cloud. A lift and shift migration is non-disruptive to the application because it replaces on-premises storage and compute resources with the same type of technology in the cloud, while also enhancing scalability and agility. So let's talk about hybrid cloud solutions. Similar to what we just talked about, many customers want to take advantage of the economies of cloud storage, but they have applications running on-prem that require their most active data sets to be cached locally. Customers can use AWS Storage Gateway as a file storage or block storage target for these hybrid cloud workloads. It's easy for customers to store all of their data durably in the cloud while keeping a copy of their active data set cached on the Gateway appliance. Other customers use AWS DataSync to create copies of their on-premises data in the cloud so they can run analytics using data generated on-prem in an Amazon S3 or EFS-based data lake. Because data has so much value, over the last number of years, customers have accumulated a ton of it. But a lot of that data lives in different silos. And it's really hard to do analytics having to go to all those different data silos. So what you really want to do is compile all that data together in a consolidated data lake. By far, the most popular data lake today is S3. And there are a number of reasons why people consider S3 the best solution for a data lake. First of all, if you look at the operational performance and availability and reliability over the last 13 years that S3 has been around, S3 is really unmatched. We do a lot of things to make that possible. Our multi-AZ storage classes replicate your objects across a minimum of 3 AZs for greater durability. Those AZs are at least a mile apart, and in the vast majority of cases, they're more than 10 miles apart. We're the only cloud provider that our architects like this in a single region. And if you want to replicate your data between regions, you can just enable that feature on any storage class and then choose any region and any storage class as your target. No one else allows you to do that. S3 is also more secure. It's the only storage service that allows you to see every API access to every data and event. It's also the only storage service that integrates with a service like Amazon Macie, which uses machine learning to classify your data into different categories and then lets you know if there is any anomalous movement or activity to that data. S3 is also the only storage service that lets you operate at a fine-grained level at the object level. Other storage services force you to operate at the bucket or account level. And the reason it's so useful to operate at the object level is so you can do things like setting editable tags that do almost anything, like tier those objects to move into lower cost storage tiers or replicate only your most valuable data using cross-region replication. You can also set access control policies and security policies. S3 is the only storage service that automatically looks at all of your storage access patterns and then does analytics for you and suggests which objects you should move to a lower cost storage tier. S3 makes it simpler to get your data in, with more ways to transfer data into S3 than anywhere else. From the Snow family for offline data transfer to the Kinesis family for streaming data, to S3 transfer acceleration and Storage Gateway for online transfers. With S3, you can build your own data lake from the ground up, or with the new AWS Lake Formation service. With Lake Formation, you'll have a simplified data lake setup, including blueprints, a central catalog for fine-grained access control and data discovery, and built-in ML-based data cleansing and deduplication. With the central catalog, you also get a central point of audit and governance. No charge for lake formation, by the way. You only pay for the underlying resources. This is why so many people are using S3 as their data lake. So now let's dive deeper on some of the services, and we'll start with Amazon S3. S3, as I mentioned before, is an object storage service providing industry-leading scalability, data availability, security, and performance. Here's just some of the key benefits. It is fully integrated with our AWS analytics services, Amazon Athena, Amazon Redshift, and Amazon EMR. This means customers do not have to perform resource and time-intensive ETL jobs to get their data into another data source to run analytics applications. S3 also has S3 Select, which lets customers retrieve subsets of object metadata instead of the entire object, which can improve query performance by up to 400%. Customers can also use AWS Lake Formation, as I mentioned before, to stand up and secure a data lake on S3 in days as opposed to weeks or months. S3 is also integrated with Amazon FSx for Lustre, a fully managed file system that is optimized for compute-intensive workloads, and I'll talk more about that in a bit. This means customers can run their HPC, machine learning, and media data processing workloads across their S3 data without additional ETL steps. Amazon FSx for Lustre works by copying data from an S3 bucket, allows you to run workloads, and then write the results back to S3. Today, AWS is the only object storage service that lets customers manage their data on the account, bucket, and object levels, as I mentioned before. Customers can append up object tags to an individual object, which are then used to identify specific objects to replicate across regions, restrict access to, or transfer to cheaper storage classes, among other operations. S3 also supports S3 batch operations, and that allows customers to take actions against thousands, millions, or even billions of objects with a single API request or just a few clicks in the S3 management console. All S3 customers can create and enforce access policies that align to business operational compliance, security, and governance across their data. Customers can configure resource-based access policies with bucket policies and access control lists, also known as ACLs, or user-based policies to define user access within an AWS account. Customers can also use time-limited URLs to grant third-party access to specific S3 resources for a limited period of time. For organizations that want to restrict any and all public access to their data, they can use S3 Block Public Access to configure and enforce a no public access policy for a specific bucket or even an entire account. All S3 customers can store their data across 6 distinct storage classes that are designed to accommodate different access requirements at corresponding costs. Customers can use S3 storage class analysis to learn the access patterns of their data and configure lifecycle policies to transfer less frequently accessed objects to cheaper classes or archive them into S3 Glacier Deep Archive for maximum savings. Amazon S3 also saves costs for data with changing or unknown access patterns with S3 Intelligent Tiering, the world's first machine learning-driven object storage class. It automatically moves data to 2 access tiers, one optimized for frequent access and a lower cost tier optimized for infrequent access. All of this is based on changes in access patterns and subsequently delivers cost savings. S3 supports many auditing tools so that customers have transparency into what they're storing at the bucket and account levels, who is trying to access what data and from where. Object metadata such as storage classes, retention date, business unit, and encryption status, access policies, costs and billings, and access patterns. With these insights, customers can make productive changes to optimize their data and the applications that rely on it, and reduce storage costs associated for their data. Not only is AWS global infrastructure designed for the most data-sensitive companies in the world, we also manage compliance requirements, such as PCI DSS, HIPAA High-Tech, FedRAMP, EU Data Protection Directive, and FISMA to help customers meet regulatory requirements. This means customers can work with AWS services in a secure environment that has been verified by third parties. AWS also offers security, compliance, and identity management tools that can be used to mitigate errors and threats, detect vulnerabilities, configure access controls, and audit activities within their respective S3 environments. S3 is also integrated with Amazon Macie, which I mentioned before, which customers can use to discover, classify, and protect sensitive data stored in S3. S3 is designed for 11 nines of data durability, which makes it the most operationally performant and available object storage service. We maintain this level of durability by automatically creating and storing copies of all objects uploaded to S3 across a minimum of 3 devices within an AWS region. Our multi-availability zone S3 storage classes store copies across a minimum of 3 AZs, which are typically separated by several miles to reduce the risk of site-level failure. To decrease regional latency and increase global resiliency, customers can also use S3 cross-region replication to replicate objects across AWS regions and enable a full multi-region resiliency model. Customers can scale their storage resources up or down in minutes instead of days to weeks to accommodate fluctuating capacity requirements in near real time. S3 gives customers the freedom to ingest and store as much data as needed for big data analytics applications, machine learning, or HPC workloads. And customers also only pay for what they use, unlike on-premises data centers. At AWS, security is at the core of everything we do. Data stored in AWS is secure by default. You actually have to make a series of selections to expose your data to the public. But it's no secret there are customers who have incorrectly configured S3 buckets, making some of their data public. So we've done a lot in the last year to help you avoid those kinds of mistakes, such as launching S3 block public access. S3 is the only cloud storage service that gives you the ability to easily and systematically block public access to any new or existing storage at either the bucket or account level with S3 block public access. By default, new S3 bucket settings do not allow public access, but customers can modify these settings to grant public access using policies or object level permissions. The Amazon S3 block public access settings override existing or newly set S3 permissions that grant public access. This new configuration, which can be set in the console, CLI, or API, makes it easy for account administrators to set up a centralized control in security configurations, regardless of how an object is added or a bucket is created. AWS recommends applying S3 block public access settings to any S3 bucket or AWS account that does not require public access. Amazon S3 block public access is also integrated with AWS Trusted Advisor, bucket permissions checks, AWS CloudTrail logs, AWS CloudFormation, Macie, and Amazon CloudWatch, and it's all free and available in AWS regions. Now let's shift gears, talk a bit more about storage classes. I won't read through each of the different S3 storage classes. What's important to note is that beyond the standard storage class, we have S3 intelligent tiering, which I've already talked about a little bit. And we also have infrequent access tiers for our lowest archive tiers, S3 Glacier and S3 Glacier Deep Archive. You can take advantage of these storage classes and save costs without sacrificing performance by storing data across the different S3 storage classes, which support different data access levels at corresponding rates. You can also use S3 storage class analysis, as I mentioned before, to discover data that should move to a lower cost storage class based on access patterns and configure an S3 lifecycle policy to execute that transfer. All right, let's shift our attention to block storage in Amazon EBS. So let's start with the question, what is Amazon EBS? Well, EBS is essentially a block storage as a service that provides dedicated access to Amazon EC2 compute instances, allowing you to decouple your compute and storage. It has the flexibility to allow you to create, attach, and manage your volumes through an API, provides options for SSD or hard disk drive-based volumes, it supports encryption, which is on by default, by the way, and also provides point-in-time snapshot support to back up your volumes, which, by the way, can be managed using AWS Backup to help support coordinated application and workflow-based backup policies. All blocks for EBS are written to EBS volumes are replicated, which allows us to deliver durability, availability, and performance. EBS volumes are highly available, designed for 5 nines of availability, EBS volume data is replicated across multiple servers in an availability zone to prevent the loss of data from the unlikely failure of any single component. Based on our annual failure rate, EBS volumes are 20 times more reliable than typical disk drives. To illustrate our 0.1 to 0.2% annual failure rate, if you have 1,000 EBS volumes running for a year, you should expect 1 to 2 will fail, which, by the way, that's where snapshots come in. The snapshot feature, along with DLM, of course, make it easy to back up your data and avoid losing anything. Let's talk a little bit more about how EBS works. Although the EBS volume appears to be a single disk on the EC2 instance, EBS is not a single disk. We don't go to the AZ and associate a single disk for your Amazon EBS volume. EBS volumes are many disks represented as logical volumes. It's a highly distributed service deployed within an availability. You can easily move an EBS volume between EC2 instances. We see customers using this feature to decouple compute from storage. For example, customers rebalance Cassandra clusters in this way. We also see customers moving data volumes between compute hosts. Could you imagine doing this on-prem today at scale? Multiple volumes to one instance can be configured, but not multiple instances per volume. So again, this is a one-to-one relationship, so that's important to understand versus file sharing storage, which I'll talk about in just a bit. We have two SSD-based volume types, IO1 and GP2. I mentioned them a little bit earlier. We've had some improvements. IO1 now delivers up to 64,000 IOPS and 1,000 megabytes per second throughput per IO1 volume. And when attached to, and that's when it's attached to a Nitro-enabled instance. And it's ideal for critical applications and databases that need high sustained IOPS. If you don't need the super high IOPS but still need SSD level performance, then GP2 offers a perfect solution and is great for boot volumes and low latency applications and bursty databases. As mentioned earlier, we improved peak performance on GP2 by 60%, and depending on your volume size, you can see performance up 16,000 IOPS or throughput to 256 megabytes per second. If IOPS is less critical and lower cost and throughput is a priority, then the hard disk-based ST1 and SC1 volumes are a better choice. With ST1, you can get 500 megabytes per second of throughput, which, by the way, is 2 times faster than what you'll see with GP2 at a lower cost. And if your throughput performance is not that high, you can save even a bit more money with SC1 volumes. So what's the number one question I always get regarding EBS volumes? Which one do I select? So many options. Well, we closely monitor the performance of our EBS fleet globally and found that GP2 handles nearly all of our customer workloads. So the answer, start with GP2. What if you find you actually needed a different performance characteristic? What if the performance requirement was high initially for applications such as log collection and media transcoding, but then the access patterns were slower and you didn't need the performance? What if you need the hydration performance you get with IO1, but you don't need the IO1 performance long term? We have an answer for all of that: elastic volumes. So elastic volumes offer the flexibility of changing volume types and increasing the size of the volume. If that wasn't cool enough, you could also do this in production with no impact to your environment, changing from hard drive to SSD or vice versa, live in production. That's awesome. How about starting small and growing your block volume as your data requirements change over time? Could you imagine doing that in the old world? With EBS and elastic volumes, you have a best-of-breed block storage service that can be modified on the fly as needed. So, quick summary. We do continue to make significant investments to improve performance in EBS, and we're going to continue to do so. EBS is our primary solution for durable, high-performance storage for your instances. We like to think of EBS that has 3 main things. It's simple to use, it's performant for customer needs, and it's reliable. We know you aren't always going to know what your application requirements are ahead of time, and we also recognize these change over time. We are the only cloud provider that lets you adjust your volume, both size and performance, on the fly with no disruption to your workloads with elastic volumes. Our customers love point-in-time snapshot capability. Snapshots allow customers to back up data on your EBS volumes. Snapshots are incremental, which means you save on costs, only backing up the data that has changed since the last backup. Data Lifecycle Manager was launched last year and provides simple automatic backups and retention schedules for your snapshot creation based on lifecycle policies. With DLM, you don't need to use custom scripts to manage your backups or snapshots. Everything is simple, automated, and managed for you. EBS performance is going to meet the vast majority of customers' needs, but we know some customers are very sensitive to performance. So as I mentioned earlier, we've doubled the peak performance for IO1 SSD volumes and improved peak performance for GP2 by 60%. Reliability is often what it comes down to when choosing to migrate to the cloud. And with EBS being one of our fundamental solutions, reliability and security are priorities as we continue to grow our performance and simplify things for you. What we have found crucial is that all companies, but especially enterprises, need security and control over their data. Key management service encryption ensures full control over security in your organization. EBS used the highly reliable and secure key management service for encryption. When you attach an encrypted EBS volume to an EC2 instance, data stored at rest on the volume, disk I/O, and snapshots created from the volume are all encrypted. All EBS volume types support this feature, and you simply access encrypted volumes the same way that you access other volumes with no additional actions. So let's talk about file systems, starting with Amazon EFS. We launched Amazon EFS in 2016 to provide customers with a fully managed service, providing a simple, scalable, elastic file system for Linux-based workloads. EFS is great for broad range of business applications and use cases, such as web serving and content management, media and entertainment workflows, big data analytics, container storage, database backups, and other development tools. Essentially, for most any Linux-based application that needs a scalable, durable, highly available, high-performance file system, EFS is the right choice. It's elastic and scalable. EFS is elastic scaling up or down as you add or remove files, giving you the storage you need when you need it. Your performance scales as your capacity grows, which, by the way, can scale to petabytes in a single file system. EFS gives you high performance. EFS supports two performance modes, general purpose and max I/O. You can configure your file system to get the best results for your particular business needs. EFS also has two throughput modes. The default burst throughput mode is ideal for those spiky workloads that need higher performance, but only for short periods of time. And we announced last year a second provision throughput mode for applications that need higher dedicated throughput than the default bursting mode provides. Provision throughput can be configured independent of the amount of data stored on the file system, so you can get exactly the performance you need all the time. And just to put your mind at ease, for those of you with super demanding workloads, Amazon EFS can support performance of over 10 gigabytes per second and up to 500,000 IOPS. We do have two different storage classes. We announced at reInvent in 2018 a new infrequent access storage class and lifecycle management to help you better optimize your EFS storage costs for files that don't need access every day. Once launched, we have the standard and the new infrequent access storage classes that will allow you to optimize your storage based on actually how often it's accessed, based on four different policies. And the bottom line is all data that's moved to EFSIA can save you up to 92% of the cost of EFS. EFS provides shared access. It supports thousands of connections from EC2 or on-premises servers over AWS Direct Connect or AWS VPN. We also have the ability for instances in another AWS account or in another VPC to access your file system, meaning you can now access your file system across AZs, regions, VPCs, and accounts. It's highly available and durable. EFS is also designed similar to S3 for high availability and durability. All files and directories are redundantly stored within and across multiple AZs in a region to prevent data loss from any single component failure. It's also secure and compliant. EFS, you can securely access your files using your existing security infrastructure. You can control access with POSIX permissions, VPC access controls, and with IAM. You can also encrypt your data at rest and in transit. EFS also meets many of the eligibility and compliance requirements, helping you meet all of your regulatory needs. So customers have been hungry to move more of their file system workloads to AWS. I talked about EFSIA a little bit. We've had the opportunity to understand the many use cases and applications they're running. In addition to applications, customers using EFS to store things like backups or log files that they don't need access to very often. Others upload shared documents, raw data, for immediate analysis, and these files generally see frequent activity right after upload with a significant drop-off as they age. Within Amazon EFS's new pricing, using the industry-accepted 80-20 rule, 80% of your data is cold, or not accessed very often, and 20% of your data is hot, or actively used. You can now store petabytes of data in your cloud file systems at an effective price of just 8 cents per gigabyte per month. In these cases, customers still love the durability of EFS because the data is important, but because the data isn't used all that much, they're less concerned about speed and performance. A lot of times, these customers move this data into a lower price storage option like S3 storage classes. This takes work. Prior to EFSIA, they would have to transform that data and then move it, which adds some complexity and time. They could build scripts and workflows to automate some of this, but wanted an easier way. EFSIA does this, offering not only the 92% savings for infrequently accessed files, but also requires no changes to their applications and leverages lifecycle policies to automatically move the data to EFSIA. EFS is a distributed file system. Because of this, there's some best practices that I like to share that will help you maximize your performance and get the most out of your EFS file systems. First, test with GP or general purpose mode and start with the bursting throughput mode. These are the default performance and throughput modes. If you need more performance than what you're getting with bursting mode, you can leverage provision throughput. Next, use Linux kernel 4.3 or newer. We recommend also using EFS Mount Helper. This is a wrapper that is executed to mount the file system with NFS 4.1 and with all the recommended mount options. Use large I/O sizes whenever possible to take advantage of the file system's characteristics. Along those lines, use multiple threads or other tools such as parallel I/O. Use multiple instances to access the data, and use multiple directories to make the data more accessible and broad by those different instances. And finally, monitor the metrics in CloudWatch so you know if your file system is at peak performance. So sticking with file system, let's talk about FSX now. We launched FSX at reInvent in 2018, but when we first looked to provide a shared file storage service for Windows applications, we looked at implementing the SMB protocol on a non-Windows file system, which is what other providers do, by the way. And we started to realize that we couldn't deliver the right experience for customers. And that's because for Windows applications, it's the file system itself that is important. Tacking on the SMB protocol onto a non-Windows file system doesn't make it a Windows file system compatible. For full Windows compatibility performance, you really need a file system built from the ground up to work with Windows. Based on what our customers told us, we decided the most customer-focused course was to deliver a native Windows-compatible offering built on Windows Server. Amazon FSX for Windows File Server provides a fully managed Windows file server so you can easily lift and shift your Windows applications to AWS. And just like with EFS, you pay for only the resources used with no upfront costs, minimum commitments, or additional fees. It provides native Windows compatibility. Our customers have spoken and we listened. Built on Windows Server, you get native Windows file storage that you can access over SMB that supports the Windows file system features that you use today and works seamlessly with the Microsoft Active Directory. It's fast and provides flexible performance. Built on SSD storage, Amazon FSX provides fast performance with per file system throughput up to 2 gigabytes per second, tens of thousands of IOPS, and consistent sub-millisecond latencies. Similar to EFS, you can pick throughput levels independent of your file system size. Performance can scale up to tens of gigabytes per second of throughput across hundreds of petabytes of data by using DFS namespaces. It's enterprise ready Amazon FSx provides the features, performance, and security that enterprise applications like ERP, CRM, or even .NET applications or home directories rely on. It provides the throughput, IOPS, and consistent sub-millisecond latencies needed for those enterprise workloads. It has broad accessibility. By supporting the SMB protocol, you can connect your file system to Amazon EC2, VMware Cloud on AWS, Amazon Workspaces, and Amazon AppStream 2.0. With Microsoft Active Directory support, you get integration with the current Windows environment and distributed file system, or DFS, which supports multi-AZ deployments. Amazon FSx supports creating multiple file shares for each file system across multiple instances. As mentioned before, it's fully managed and simple to deploy. You no longer have to worry about setting up and provisioning file servers and storage volumes, operating Windows file server software, and dealing with updates and patches and manually performing backups. In minutes, you can easily create a fully managed file system with automatic backups by using the AWS Management Console, CLI, or AWS SDK. It's secure and compliant. All of your data is automatically encrypted at rest and in transit. Amazon FSx for Windows File Server is PCI DSS compliant and HIPAA eligible. You can control user access with Windows Access Control Lists or ACLs, and all of your data is protected by automatic, highly durable daily backups. It uses Windows Access Control Lists for file access control, integrated with CloudTrail monitors and logs your API calls, letting you see actions taken by users on your resources. And finally, it's cost effective. You pay only for the resources you use with no minimum commitments or upfront fees. With EFS and FSx for Windows, we provide customers with file systems that are great for the vast majority of business workloads. However, customers with HPC or compute-intensive workloads came to us and asked for help in addressing their needs for a fully managed cloud file system solution to meet their needs. Many compute-intensive workloads require the high performance of scale-out parallel file systems. Operating these file systems requires expertise and administrative overhead, requiring you to provision storage servers and tune complex performance parameters. With FSx for Lustre, you get a fully managed Lustre parallel file system. Because it's a Lustre file system, its performance is ideal for compute-intensive workflows with high throughput and low latency needs. Amazon FSx for Lustre is fully managed file system and is optimized for compute-intensive workflows, as I mentioned, for workloads like machine learning and media and entertainment workflows. With Amazon FSx for Lustre, in minutes, you can launch and run a Lustre file system that can process massive data sets, and you pay for only the resources used with no minimum commitments, upfront hardware fees or software costs, or additional fees. It is massively scalable with performance. FSx for Lustre provides throughput up to hundreds of gigabytes per second, millions of IOPS, and consistent sub-millisecond latencies. When you have spikes in capacity demand in your data center, you can burst data into Amazon FSx for Lustre with Amazon Direct Connect and VPN. And this is one of the coolest things. It seamlessly integrates with S3. Not only do you get amazing performance, but you can store and retain inactive data sets in Amazon S3 using FSx for Lustre for analysis. Just like EFS and FSx for Windows, it's fully managed. As a fully managed service, Amazon FSx for Lustre manages the hardware provisioning and maintenance, software configuration, and complex performance tuning, so you can focus on your compute-intensive workloads. It's compatible with your applications. The Lustre file system is POSIX compliant, so your applications can work with files and directories just as they do with the local file system. It's cost-effective. Amazon FSx for Lustre is cost-optimized for short-term compute-intensive workloads by providing non-replicated storage. Using FSx, you can spin up and spin down file systems as needed and store long-term data in S3. Just like EFS and FSx for Windows, FSx for Lustre is secure and compliant. Your data is automatically encrypted at rest. FSx for Lustre is PCI DSS compliant and HIPAA eligible, making it easy to meet regulatory standards. All right, now let's talk about some of the hybrid edge and data transfer. Once customers decided to move their data to the cloud, AWS has many ways, more than anyone else actually, to get data in depending on the nature of the data and application. We have Direct Connect, which is private connection between an on-premises data center and an AWS region. For streaming data, customers can use Kinesis Firehose. To send data in bulk, customers can use Snowball, Snowball Edge, or Snowmobile. AWS DataSync is a data transfer service that automates transferring and synchronizing data from on-premises NAS over the network to S3 and EFS. It speeds up to 10 times faster than open source tools like rsync or Robocopy. And for companies that need to use SFTP to move their data, we have AWS Transfer for SFTP. No matter what the use case is, we have a data transfer method that fits perfectly. Let's dive in a little bit. On the hybrid side, we have AWS Storage Gateway. It's a hybrid cloud storage service that gives you on-prem access to virtually unlimited cloud storage. Customers use Storage Gateway to simplify storage management and reduce costs for key hybrid cloud storage use cases. It supports multiple storage protocols. This is super important. Storage Gateway supports standard storage protocols to enable companies to seamlessly connect on-premises applications to AWS storage without having to modify existing applications. It has local caching. It means Storage Gateway manages the local cache and offloads the data that's not accessed frequently to the cloud based on your desired performance parameters. So you can fine-tune the balance of latency and scale for your workloads. It has optimized data transfers. This means the service includes a highly optimized data transfer mechanism with bandwidth management, automated network resilience, and efficient data transfer. Data stored through AWS Storage Gateway benefits from the durability and security embedded in AWS clouds and other AWS cloud storage services. Storage management tools like versioning, cross-region replication, and lifecycle management policies can lower the cost of long-term archiving, simplify audit and compliance requirements, and safeguard all your data, not just the parts kept on-prem. Cloud storage is delivered and built on demand, so you always have just the right amount. Workloads can expand and contract. Backup and archive storage can expand without upfront media costs, and you can provision additional storage capacity without new hardware. And finally, storage gateways are easily managed via the AWS console. And most importantly, once your data is in the AWS cloud, it can be queried, accessed, and used across the entire portfolio of AWS applications and services. So AWS DataSync is a data transfer service that makes it easy for you to automate moving data between on-prem storage and Amazon S3 or Amazon EFS. DataSync automatically handles many of the tasks related to data transfers that can slow down migrations or burden your IT operations, including running your own instances, handling encryption, managing scripts, network optimization, and data integrity validation. It's fast. You can use DataSync to transfer data at speeds, like I mentioned before, 10 times faster than open source tools. It's automated. DataSync automates both the management of data transfer processes and the infrastructure required for high performance secure data transfer. The service also includes automatic encryption and data validation. All of this minimizes the in-house development and management otherwise needed for fast, reliable, and secure transfers. It supports one-time migrations or ongoing transfers. The service enables you to do the one-time data migrations, recurring data processing workflows, and supports automated replication for data protection and recovery. It's very flexible as well. DataSync supports flexible configurations to suit your specific needs, including bandwidth throttling, and copying source permissions and metadata. It's highly integrated into AWS. Getting started with DataSync is super easy. Deploy the DataSync agent on-prem, connect it to a file system or storage array, select Amazon EFS or Amazon S3 as your AWS storage, and start moving data. It's also secure and compliant. All of your data is encrypted in transit and at rest. And for each transfer, the service performs integrity checks. These checks ensure that the data written to your destination matches the data read from your source, validating consistency. DataSync also makes sure that your data arrives securely, intact, and ready to use. Let's talk about transfer for SFTP. Securely sharing files using SFTP is imperative for many businesses, but running your own servers and infrastructure can be an operational hassle. AWS Transfer for SFTP fixes all that. It has seamless integration for SFTP migrations. You can Migrate SFTP-based workloads to AWS without changing your existing authentication systems, domains, and host names. So nothing changes for your partners, customers, or even your internal teams. It's fully managed within AWS. As a fully managed service, Transfer for SFTP enables the secure transfer of files into and out of Amazon S3. It's simple. Getting started is simple since there is no infrastructure to set up. AWS SFTP manages the infrastructure behind your SFTP endpoint for you, which includes auto-scaling capacity and maintaining high availability with a multiple AZ architecture. Like everything else we've talked about today, it's secure and compliant. AWS SFTP makes it easy to support recurring data sharing processes, as well as one-off secure file transfers where setting up access to internal systems for external teams is difficult and practical. The underlying security of the SFTP protocol transfers commands and file data through a secure encrypted channel. It's cost effective. Like everything else we've talked about, you only pay for the resources that you use, the time your SFTP server is provisioned, and the amount of data that is transferred. There are no upfront costs and no resources to manage yourself. It has native integration with AWS services. Because AWS SFTP stores your data in S3, you can use it easily with API-driven data processing and analytics workflows, unlike third-party tools that may keep your files in silos. AWS SFTP is also natively integrated with AWS management services, simplifying your security, monitoring, and auditing. So now let's talk about offline transfers. The AWS Snow family of services offers a number of physical devices and capacity points, including some with built-in compute capabilities. These services help physically transport up to exabytes of data into and out of AWS. The Snow family of services are owned and managed by AWS and integrate with AWS security, monitoring, storage management, and computing capabilities. First, there's AWS Snowball. Snowball is a data transfer solution that accelerates moving terabytes to petabytes of data into and out of AWS using storage appliances designed to be secure for physical transport. Using Snowball helps to eliminate challenges that can be encountered with large-scale data transfers, including high network costs, long transfer times, and of course, security concerns. Snowball Edge is a little bit different. Snowball Edge devices contain slightly larger capacities and an embedded computing platform that helps you perform simple processing tasks. They can be rack shelved and may also be clustered together, making it simpler to collect and store data in extremely remote locations. Customers use these devices in environments with intermittent connectivity, such as manufacturing, industrial, and transportation, or in extremely remote locations, such as military or maritime operations. Before shipping them back to AWS, they can do all their compute on site before shipping them back to AWS data centers. AWS Snowmobile moves up to 100 petabytes of data, equivalent of 1,250 AWS Snowball devices, and a 45-foot-long ruggedized shipping container. It is ideal for multi-petabyte or exabyte scale digital media migrations and data center shutdowns. A Snowmobile arrives at the customer site and appears as a network-attached data store for more secure, high-speed data transfer. After data is transferred to Snowmobile, it is driven back to an AWS region where the data is loaded in Amazon S3. I know this can all seem overwhelming, but remember, your migration to the cloud is a journey. Migrating to the cloud simply doesn't happen overnight. It can happen in stages or can be deployed in pieces depending on your business needs. You can start with lift and shift, which is also referred to as hosting, where you may be looking to migrate an application to the cloud as quickly as possible to meet an urgent business need, where the scalability and flexibility of the cloud can get you past a difficult challenge. There are other strategies for migrating to the cloud that will allow you to unlock more of your unique benefits by moving your workloads to AWS. You can take things one step further and re-platform your applications with just a few cloud optimizations. For example, you may be looking to reduce the amount of time you spend managing database instances by migrating to a managed relational database service such as Amazon RDS, or migrating your application to a fully managed platform like AWS Elastic Beanstalk. To really maximize the benefits and cost savings of the cloud, you can re-architect your applications. Typically, this is driven by a strong business need to add features, scale, or performance that would otherwise be difficult to achieve on-prem. If your organization is looking to boost agility or improve business continuity by moving to a service-oriented architecture, this strategy may be worth pursuing. For example, you could re-architect your on-prem solution to run completely cloud-native and migrate your storage to a data lake on S3, your databases to Amazon Aurora, and leverage the modularity of containers and use Lambda for serverless compute. So what to choose? Let's talk about that. So block storage is great for that dedicated one-to-one instance to storage solution. Because EBS provides persistent local storage for Amazon EC2, it's ideal for databases like Microsoft SQL Server and MySQL or Cassandra and MongoDB. Data warehousing like Vertica and Teradata. File storage solutions are an ideal choice for lift and shift migrations where you have applications using a shared file resource on-prem. Migrating home directories for users and groups is always a good place to start. You can take advantage of the built-in native network file protocols with EFS and FSX for Windows, and leverage FSX for Lustre for your high performance and data processing workloads. Object storage and S3 are great for your cloud-native applications and specifically for data lakes. It offers the lowest cost solution for backup, recovery, and active archive solutions with S3 Glacier and Glacier Deep Archive. S3 is also a great landing place for hybrid storage scenarios when you have data on-prem that you would like to process in the cloud. And if you need that hybrid setup or need to transfer data to the cloud, as I just talked about, we have DataSync to move data to AWS storage services such as AWS EFS and S3, as well as S3 Transfer Accelerator to move data quickly. We also have Transfer for SFTP when that's your protocol of choice. Hybrid scenarios using Storage Gateway, such as File Gateway for NFS or SMB workflows backed by objects in the cloud. Tape Gateway for VTL, where virtual tapes reside in S3 or Glacier Deep Archive, or even Volume Gateway, when you need to present cloud-based iSCSI block storage volumes to your on-prem applications. And then, of course, there's the Snow family for all of your offline data storage movement. Lots of information today, so with that, I'll wrap up. I'd like to thank everyone for their time today and wish you all good luck on your journey to the cloud.